Okay, good evening everyone. This is Dean here from the University of Limerick, and this is the elements method for constructing the hyperboloid of revolution. So in this question we're given the plan of the base and the top of it as well in this scenario. So we have a base here on the XY line, and we have a top as well up here, which is the same radius as we can see here in plan. And we're also given the throat circle. So being given the throat circle, we can get it in our elevation too, as it's halfway up from our elevation. So the throat circle, from my previous slide, as we've seen already, we know that one of the most important principles around this topic is that a hyperboloid of revolution is made up of straight line elements. So each element forms a tangent to the throat circle. So all the elements are going to be tangents to this throat circle, which I'll be going through there shortly. This is going to be put into practice there by me in a few minutes, okay? So as we can see from our question here, this is method 1, alright, of 3 methods that I'm going to go through in videos. So we're given the base circle, throat circle, and the height of the hyperboloid of revolution. So it's asking us to construct the shape using elements. Okay, so starting off, what I would do personally is I would divide this up 360 degrees. Or sorry, I divide this up 60 degrees, okay? So like so. We're only dividing up the throat circle, okay? 60 degrees. Like so. Okay, so when we've this done now, we can literally go perpendicular to each one of these 60 degree lines out towards our base circle. Okay. Okay, and we can also use the bottom of our throat circle as points. 30 degrees here again, 60 degrees, $90 here, 60 again, and 30, and horizontally as well. Okay, so there are all our elements that are going to make up our, that are going to be construction lines basically for our hyperboloid of revolution. Okay, so in our plan, as I've mentioned already in previous slides, a very important principle is that the two lines that are perpendicular to our conjugate axis are going to be asymptotes, okay? So this is one here, and this is the other one, and I'll just put them in dark so we know which ones they are, alright? So these asymptotes, as I've mentioned already, when we see these in elevation, they're going to be true lengths when we're looking at our hyperboloid of revolution, okay? So we'll just begin now by labeling our points, which will make things a lot easier for us when we get to constructing it in elevation. So this is 1, so the same line, the same asymptote is going to be 1 as well. 2 and 2 down here, the end of the line. 3, 3, 4, 4, the perpendicular line. There's another line here, 5 and 5, 6, just put a comma beside the numbers if they're right beside each other, 6 and 6, the horizontal line here is going to be 7 and 7, okay, the one beside 4 is going to be 8 coming up here, and 8, 5, 9, and that goes up to here. So just put it up there like that. Okay. And 10 and 10 is going to be going vertically up like this. So we're going to have 2 there. Okay. And yeah, that's all of our points there. Okay. So now what I'm going to do is we're going to project straight up to our elevation with these points. Okay. So these are already projected up. 8 is already projected up. So 1, 9 and 7 are going to be projected up here. Okay, like so. And similarly, some of these points will overlap. So they're all going to be, sometimes all the points are going to be brought up together. Maybe 2 or 3 points, like so there. 3, 5 and 9 are already up. 4 and 8 are already up. These lines are little in line with each other, so they can go up together. And then 2 and 6. So now I would personally myself, I'd label them in elevation as well. So there's 8, there's 8. So 1, 7 and 9. 1, 7 and 9. Okay. 2, 6 and 10. 2, 6 and 10. 3, 5, 9 in the center. I just personally like labeling them so I can match them up quicker when I get to elevation. Okay, so here's 4 and 4, which is going to be literally vertical, so that's going to be around the middle. That's going to help our curve. Okay, and we'll get to that soon. 8 is also here. Okay, 1 and 1. So there's going to be, so when we're doing our elements, as you've seen, as I've been doing it, we're always going to have, so for example 9 is here, this line, so 9 is going to be here on our base, and it's going to also be on the top. There's going to be 2 points for each side of the line. Okay, same as here, 9 is here and it's also up here. They're going to crisscross, as I'll show you soon enough. Okay, so 1 and 1 and 5, 3, 5 and 7, sorry. 1, 3, 5 and 7. Okay, and 2 and 6 is here, and 2 and 6 is also here. So now we can start joining these up. Alright, like so. So 8 comes down to here, so 8 is going to be up here. Okay, it's also going to be crossing to be down here as well. Alright, next we can join 1 to 1, so 1 goes to up here. Alright, 2 goes to down here, which is going to be up here, and that will also crisscross. They all crisscross each other, just remember that. It's very important to remember that. So it's down here as well. Alright, just make sure you have it all lined up correctly. 3 goes to 3 here, which is all there. Can you see that some of them have similar points? Okay, and as you can see now, the curve is kind of starting to form there. So 4 goes vertically, which is already joined. Okay, so 5 then comes down here, so here's the point 5, and it joins up there, which is already joined for us. 5 is here, it's not joined up here. Okay, so we can do that there now. Okay, so 6 comes down here like that, so 6 is going to be in the middle. 6 isn't labelled there, we'll just put it in. Okay, another element on our curve. Alright, 7 is horizontally across, so what we know about 7 now is it's going to be our asymptote, which means also that it's our true length in elevation. So what I'm going to do here is I'm going to put it in with my fine liner pin, so just that it stands out, okay, and that we know that it's our true length. Okay. Alright, so there it is, stands out there. So we can do the same for the crisscross of that, the other 7 and 7. We'll just join them up like that. So these are true lengths. The reason being, as I've mentioned already, is because in plan we can see our asymptote is perpendicular to our conjugate axis, which means it's going to be a true length in elevation, like so. Okay, so we're getting there now. So here's 8 and 8, so it's up here, is here, and it's joined already for us. 8 and 8 joined already. Okay, and 6, so there's 10, and 5 and 5. So 9 and 9 join here. We're almost there. Okay, 9 and 9. 7, 7. And here. Alright, so now we can see that we can draw our curve here now. So as we now know, as I've mentioned already, once we have brought all our elements to elevation, we must draw in the curve that is going to be tangential to the most extreme elements. So what we mean by that is the most outside elements that are going to form the curve, right? So we're going to be able to see that as we go along. So as I come along with my pencil, we can draw the curve, and it's going to be easy enough to draw because we have our elements drawn already. Okay, so that's one side of the hyperboloid. Here's the other side. Okay, and a lovely curve in the middle there by our throat circle. And this is the completion of our hyperboloid of revolution. So that's going to be the base. We'll just darken it in so we'll know it's all full. And there's the top of it. Okay, so that's basically it. And now we can see that our throat circle is here in the middle, and that's the thinnest part, the narrowest part, shall I say, of our hyperboloid of revolution. All the elements, as we can see, are all tangents on the curve at some stage in our elevation, as we can see here in plan. After we went 30-60 degrees to our throat circle, we got points all around our throat circle in, and I just went perpendicular to each and every one of those. So that's it for my video in method 1 of how to construct a hyperboloid of revolution. Thanks very much for watching.